Here are the answers for the Chapter 2 review assignment. I'm going to skip around in this video and hit only some of the problems where you might need help working out the answers. The first one is number 4. We're asked to add these polynomial expressions together. Before I combine like terms, I need to take care of the fact that 3 is being multiplied to all the terms in this polynomial. This is an instance where you do the distributive property. Multiply all of them by 3. The first polynomial will stay the same. So we have 8r cubed minus 3r plus 7 minus 5r squared. And then add, and let's do the distributive property. 3 times 2r squared is 6r squared. 3 times negative 3r cubed is negative 9r cubed. 3 times negative 7r is negative 21r. And 3 times 2 is positive 6. Now we can look for like terms. Start with the highest degree terms first, which are your r to the third power terms. 8r cubed minus 9r cubed is negative 1r cubed. Now find the r squared terms. Negative 5r squared plus 6r squared is positive 1r squared. Now the r terms. Negative 3r minus 21r is negative 24r. And now the constant terms. Positive 7 plus 6 is positive 13. So we're combining like terms by adding or subtracting the coefficients of the different terms. Number 5, same situation, and again we need to do some distributive property in this part of the problem. So this one stays the same, 3s squared t minus 4st squared plus 2st. And now distribute the negative 2. Negative 2 times 2ts squared is negative 4ts squared. Negative 2 times negative 1/2 ts is positive 1 ts. Negative 2 times 5st squared is negative 10 st squared. Now do the combining like terms. If we focus on the letter s and look for the term with the highest degree in s, that would be the 3s squared t, and over here there is a minus 4 ts squared. S squared t is the same thing as ts squared. So 3 minus 4 is negative 1 s squared t. Next I'm going to look at this term that has s to the first power and t to the first power. 2st and later on plus ts. An st term is the same thing as a ts term. So this makes positive 3 st. Now look at the st squared term. Negative 4 of them minus 10 of them is negative 14 st squared. Number 6, we're given an equation with several variables and given values of all of the variables except capital F. Let's make substitutions. For the letter M, 63. For the letter V, 45. And for the letter R, 1.5. Now, type this in a calculator to evaluate. 85,050. Number 9. Solve this equation for its variable, which is the letter y. There are parentheses, so we need to do the distributive property to remove the parentheses. Negative 5 times 4y is negative 20y. Negative 5 times negative 3 is positive 15. 6 times 5 is 30. 6 times negative 2y is negative 12y. Next, let's combine like terms. 3y subtract 20y is negative 17y. There is a y term on both sides of the equation. Let's remove it from the right side by adding 12y. Negative 17y plus 12y is negative 5y. And we'll continue up here. Let's subtract 15 from both sides. We get negative 5y is equal to 15. Then divide by negative 5. Y equals negative 3. Number 10, let's solve this equation for x. This one also has a lot of grouping symbols. So let's work from the innermost grouping symbols out and start to simplify this. Looking right in this area, there is some distributive property to do. We have x plus 2, bracket, 3. Now the distributive property. Negative 5 times 1 is negative 5. And negative 5 times negative x is positive 5x. On the right side, some distributive property. 3 times x is 3x. 3 times negative 3 is negative 9. Inside the brackets, there's some combining like terms that can be done because these two constants can be combined. So we have x plus 2, and then the bracket. 3 minus 5 is negative 2. We can also do some combining like terms over here. Negative 9 plus 5 is negative 4. Let's do the distributive property again because this 2 is being multiplied to both terms in the bracket. 2 times negative 2 is negative 4. 2 times 5x is positive 10x. And let's continue up here. Let's combine like terms. On the left side, there is 1x and a plus 10x. That makes 11x. Next step, subtract 3x from both sides. 8x minus 4 is equal to negative 4. Now add 4 to both sides. 8x is equal to 0. Therefore, x equals 0. Number 11, let's solve this equation for n. I notice that in the middle area, we'll need to do the distributive property because the negative 4 is multiplied to both things in the parentheses. Negative 4 times n is negative 4n. Negative 4 times 2 is negative 8. Next up, let's combine like terms on the constant terms. I realize that there are two n terms to combine together, but I'm not going to combine them yet. Negative 8 minus 22 is negative 30. And we'll continue up here. The reason I did not combine the n terms yet, even though I could have, is it would be easier if there wasn't a fraction. I'm going to multiply all terms by 3. The 2n over 3, when you multiply by 3, will make 2n, because this denominator will cancel away when you multiply by 3. Negative 4n times 3 is negative 12n. Negative 30 times 3 is negative 90. 0 times 3 is 0. Now I'm going to combine like terms with the n's because there's no fractions anymore. This makes negative 10n. Minus 90 equals 0. Add 90 to both sides. Negative 10n equals 90. Therefore, n equals negative 9. Number 12, let's solve this equation for a. I notice all kinds of grouping symbols with terms being multiplied in front of the grouping symbols. So there is distributive property in this problem. 3 times a is 3a. 3 times the fraction 1/3 makes positive 1. Negative 2a times 5a makes negative 10a to the second power. Negative 2a times negative 4 makes positive 8a. 10 times a is 10a. 10 times negative a squared is negative 10a squared. And there's a plus a on the end. Next up, combine like terms. There's a 3a and a plus 8a. That's 11a. Over on this side, there's a 10a plus an a. That's 11a. Next, I notice some common terms on both sides of the equation. they will cancel each other away if you subtract. For example, if I subtract 11a from both sides, this 11a and this 11a will go away. I also see common terms on both sides, the negative 10a squareds. Those will cancel away if we add 10a squared to both sides. Negative 10a squared add 10a squared makes 0. So it's going to cancel here and here. What's left over on the left is a 1, and what's left over on the right is a 0. This is a false statement with no variables in it. This is when you say that there's no answer that works for A. It's an empty set. Number 13, let's solve for the letter H if we're given values for the other letters. Capital A, fill in 132. For pi, fill in 22 over 7. For R, fill in 3. And for R, again, 3. We have three numbers all being multiplied to the binomial h plus 3. Let's multiply these three numbers together to get it as a single value. 2 times 22 times 3 is 132 sevenths. And that gets multiplied to h plus 3. We'll continue up here. Next, multiply both sides by 7 to remove the denominator of 7. 132 times 7 is 924. On the right side, the denominator of 7 cancels away, leaving 132. Next, divide by the 132, and we get 7 equals h plus 3. Finally, subtract 3, and we get 4 is equal to h. Number 14, part A, solve this for h. The letter h is located here, and it has numbers being multiplied to it. The letter h also has the number 12 being divided from it. Let's remove all of those things until the letter h is alone. To remove dividing 12, you multiply by 12. That creates 12v equals pi d squared times h. The pi and the d squared are both being multiplied by the h, so to remove them, you divide by them. Let's divide by pi d squared. This creates 12v divided by pi d squared, and that is equal to h. So we've solved for h. Now in part B, let's fill in values for the other letters to find h. For the capital V, fill in 157. For pi, fill in 3.14. For D, fill in 10. Type this on a calculator. When you're typing it, you have to put the whole denominator in grouping symbols on your calculator so that the calculator knows you want to divide the numerator by the 3.14 and by the 10 to the second power. This turns out to be 6. If you filled the numbers incorrectly, but you don't get the result of 6, it means you're not typing it in the calculator correctly, and the calculator doesn't know in what order you want to do the division. Number 15, true or false? If A is greater than B, then A is less than negative B. Let's determine if this is true by considering examples. Let's try some positive numbers and see what happens. Maybe A is 3 and B is 1. Then 3 is greater than 1. Let's put our 3 for A and the 1 for B over here. Is 3 less than negative 1? No, it's not, so this one is false. For number 16, let's determine if this is true or false. If A is greater than B, then A plus negative C is greater than B minus C. We could try some numbers for A and B again to determine if this is true or false. Or we could use algebra theorems that we've proved earlier this year. Adding negative C is really the same thing as subtracting a C. And so this statement is really showing the same number being applied to both sides. This is true. Number 17, if A is greater than B, then A times negative C is less than B times negative C. This one is false. You only switch the arrow symbol when you multiply by a negative number. But what if C itself was a negative number? Then negative C would be a positive number, and you wouldn't switch the arrow symbol. Number 18, solve and graph. Let's start by doing the distributive property. D times 3 is 3D. D times negative D is negative D squared. Negative times D squared is negative D squared. Negative times D is negative D. Let's combine like terms. Two D minus D is a 1D. Next, notice that there's a negative D squared on both sides. Through addition, those will cancel away. Now let's subtract D from both sides. We get 2D plus 2 is greater than or equal to 0. Now subtract 2. We get 2D is greater than or equal to negative 2. Therefore, D is greater than or equal to negative 1. To graph, you put negative 1, close dot, and shade all the numbers greater than negative 1. Number 19, let's begin with the distributive property. 3 times 4m is 12m. 3 times negative 5 is negative 15. Negative 4 times 6 is a minus 24. Negative 4 times negative 4m is positive 16m. Next, combine like terms. 1 minus 24 is negative 23. Next, subtract 16m from both sides. 12m subtract 16m is negative 4m. Then add 15 to both sides. And divide by the coefficient negative 4. We find out that m is not equal to 2. So on a graph, put 2, put an open circle, and shade all numbers that are not the 2. Number 23, we're asked to find the solution for x, and we have an intersection of two sets. For an intersection, we want to choose the answers that are solutions to both of them at the same time. So let's focus on the first inequality. This is an absolute value, and it has a less than symbol. The way you rewrite it is to change the sign on the 7, put the less than, write down the expression that was inside the bars, put less than again, and then keep the 7. Now solve this by getting x alone in the middle. Add 1 to all places. You get negative 6 is less than 2x is less than 8, and then divide by 2 in all places. Negative 3 is less than x is less than 4. The answers that work for the first inequality are all the numbers between negative 3 and 4. But that's not the answer to our intersection. We won't know that answer until we find the solutions to our other inequality. So jump over here and let's rewrite this one. This is an absolute value and it has a greater than symbol. So here's how you rewrite it. The expression in the bars, put less than and negative 7. Then write the word or. Then put the expression from in the bars and put greater than positive 7. Now solve each of these. Add 1, we get 2x is less than negative 6. And divide by 2, we get that x is less than negative 3. Or, now let's go over on this one and solve it. When you add 1, you get 2x is greater than 8. and divide by 2, you get x is greater than 4. An intersection has the numbers that solve both of them. So we're looking for the numbers between -3 and 4. And over on this side, we're looking for the numbers that are less than -3 or they're greater than 4. Think about that a little bit. Are there any numbers that are between -3 and 4 and at the same time they're less than -3 or greater than 4? There aren't any. So this is a question where you write empty set. Number 24, we're asked to graph the solution to this absolute value inequality. We do that by rewriting it. So with a greater than symbol, the way it's rewritten is to write the expression in the bars and put less than the negative of 3, then write or, put the expression in the bars and put greater than +3. Now solve both of these. Subtract 5 from both sides. 2r is less than -8. And divide by 2. So r is less than -4. When you subtract 5 over here, we get 2r is greater than -2. And then when you divide by 2, we get r is greater than -1. Here's our solution for r. This is a description of the numbers that work for r. Let's show that visually on a graph. Here's -4. Here's -1. Less than -4 are these numbers. Greater than -1 are these numbers. Number 25. This absolute value inequality has a less than, so there's a different way to rewrite it. -9 is less than or equal to 4s minus 3, which is less than or equal to +9. Let's get s alone in the middle. Add 3 to all spots. Then divide by 4. -6 divided by 4 reduces to -3/2. 12 divided by 4 is 3. Here's our description of the solution for s. By the way, -3/2 is the same as -1.5. Here's +3 over here. We get closed dots and shade in between them. Number 26, we're asked to graph another intersection. So we have to solve both statements and then look for the answers that work for both of them at the same time. Let's focus on this one here on the left. Add 7. We get 2m is greater than or equal to 8. And divide by 2. So m is greater than or equal to 4. Now this one here, this is an absolute value with a less than symbol. So you write -5 less than or equal to m plus 1 less than or equal to 5. Now subtract 1. You get -6 is less than or equal to m, which is less than or equal to 4. And again, we're doing an intersection to join these. So what are the numbers that are greater than or equal to 4 and at the same time? They're in between -6 and +4. The only one that works is +4. Because m can equal 4 in the first one, and m can also equal 4 in that second one. Number 27. This time we want to graph the union of the solutions. So all the solutions that work here, along with all the solutions that work here. For this first one, let's subtract 1. We get -4 is less than n is less than 0. For this one over here, let's subtract 3. We get -4 is less than 2n is less than 4. And then divide by 2. We get -2 is less than n is less than 2. We want all the numbers that solve this along with all the numbers that solve this. Here's -4. Here's -2. Here's 0. Here's +2. The first statement tells us to show the answers between -4 and 0. There they are. The second statement tells us to show the answers between -2 and +2. When you shade in between -2 and +2, you're going to end up filling in that open dot on the 0. Because while 0 was not a solution to this first statement, 0 is a solution to this second statement. This picture shows the union of these two descriptions. Number 28, shade in the region of space that is the intersection of R and T. What region of space is in R and it is in T? It's this corner right here. This is inside the box for R and at the same time inside the box for T. Number 29, we're doing another intersection. The region of space that's in both of them. It has to be in R and it has to be in S. There is none. This one's empty set. Number 30, R union S. Everything in R along with everything in S. Here's everything that's in R along with everything that's in S. Number 31, we want to find the intersection of R and T and then create the union of that with the intersection of S and T. So the intersection of R and T is this spot here. The intersection of S and T is this spot here. Considering both of these together gets us our union. Number 35, solve this equation. This equation fits a special pattern that we've learned about, where things are being multiplied together on one side and the other side has 0. The technique is to take each factor and put it equal to 0. Use the word OR to connect them. This first one has already been solved, and right here if you subtract 3 from both sides, you get -3. So P equals 0 or -3. Number 36 fits that same pattern. There's a multiplication here in the middle. So this binomial times this binomial equals to 0. For two things to multiply together and equal 0, at least one of them has to be 0. So the 5n minus 3 has to be 0, or that other one has to be 0. Let's solve each of these. Add 3 to both sides, and then divide by 5. On this one here, subtract 1 from both sides, and then divide by 2. So our answer is n equals 3/5 or -1/2. Number 38, we're asked to give two interpretations of what this algebra statement might be about. For one of them, I'm going to give a very literal interpretation. And on the second one, I'm going to create a real-world situation that this might model. Here are some possible answers. A number A plus 15 more than A plus 30 less than A is equal to 180. When you read this statement, hopefully you're able to pull out the expressions and find them in the algebraic expression. For my second statement, I used a concept from geometry that the three angles of a triangle add up to 180. And I said the variable A represented the size of an angle in a triangle. The second angle is 15 more than the first, would be A plus 15. The third angle is 30 less than the first, would be A minus 30. And all three angles of a triangle add up to 180. For number 39, I'm going to approach it similarly. My first statement will be a literal translation, and my second one, I'll try to create a real-world application. For number 1, I wrote twice a number r, do you recognize that up there, plus 25 is greater than or equal to 75. For my second statement, I tried to think of something real-world. It's probably pretty silly, but I tried. 25 pounds more than, do you recognize that up here as the plus 25? Twice Ralph's weight. That's my 2R, because I was thinking of using R to represent Ralph, is at least 75. That's the greater than or equal to 75 part. Next, number 40. The word problem says, find 4 consecutive odd integers whose sum is 128. If we represent the first of the numbers by the letter x, then the next odd integer would be x plus 2. The next one after that would be x plus 4, and then x plus 6. We're told that they sum to 128. So let's add these 4 expressions together, and we'll say equals 128. Now solve the equation. Combine like terms. X, 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 and x is 4x. 2 plus 4 plus 6 is 12. Subtract 12 from both sides. You get 116. And then divide by 4. X is 29, which is an odd number, and that's good because we were looking for odd numbers. So our first odd number is 29. 29 plus 2 is 31, then 33, then 35. Number 41. The word problem tells us a number is 5 more than 4 times another. The larger number, decreased by 2/3 the smaller, gives 20 as the result. Find the larger number. The problem tells us that the larger number is 5 more than 4 times another. So if we use the letter x to be the smaller number, we can express the larger number in terms of x. It's 5 more than 4 times that smaller number. 4x plus 5 models the larger number using the first sentence in the paragraph. We're told something else. The larger number decreased by 2/3 of the smaller equals 20. Let's write that in symbols. The larger number, so I'm writing the model that represents the phrase larger number, decreased by, so that's subtraction, 2/3 of the smaller, so 2/3 x. I'm using the model that I created that represents the smaller number, gives 20 as the result, so equals 20. Let's solve this equation for x. We could combine the x terms right now, but before we do that, I'm going to multiply by 3 to get rid of the fraction. 4x times 3 is 12x. 5 times 3 is 15. When you cancel the 3 there, you get negative 2x, and then equals 60. Now combine like terms. 12x minus 2x is 10x, plus 15 equals 60. Subtract 15 from both sides. 10x equals 45. And divide by 10. So x equals 4.5. The smaller number is 4.5. We were actually asked to find the larger number. So let's fill in our value for x and figure out what the larger number is equal to. This turns out to be 23. Next, number 42. An angle measures at least 2/3 of its supplement and at most 5 times the complement. Find the possible measures of the angle. So we don't know how large an angle is. Let's represent it with the variable x. Supplementary angles add up to 180. If one of them is x degrees, the other one can be found by subtracting x from 180. Complementary angles add up to 90. If one of them is x, the other one can be found by subtracting x from 90. So these expressions model the different angles that are mentioned in the word problem. Let's try to create statements from the clues. An angle measures at least. So we can write x is greater than or equal to. The angle is at least something. 2/3 of its supplement. So 2/3 times the model that we made for supplement. And at most 5 times the complement. Let's show that one in symbols as well. The angle is at most, so less than or equal to, 5 times the complement. When I read the words complement, I'm filling in the algebra expression that we created that represents the complement. Let's solve these statements and see what it seems to indicate about x. Let's do the distributive property. 2/3 times 180 is 120. 2/3 times negative x is negative 2/3 x. Let's multiply all terms by 3 to remove the fraction. 3x is greater than or equal to 360 minus 2x. Now add the 2x to both sides. 5x is greater than or equal to 360. And divide by 5. 360 divided by 5 is 72. Let's work with this one over here and see what it outputs for x. First, the distributive property. 5 times 90 is 450. And 5 times negative x is negative 5x. Now add 5x to both sides. We get 6x is less than or equal to 450. Now divide by 6. X is less than or equal to 75. Let's put the two statements together to see what it describes as the answer for x. We want numbers greater than or equal to 72, and they're less than or equal to 75. So 72 degrees is a possible answer for x, 73 degrees, 74 degrees, and 75 degrees. Number 43. When a rectangle is formed by doubling the length of a side of a square and decreasing the length of the adjacent side, the perimeter of the rectangle is 10 feet greater than that of the square. Find the dimensions of the rectangle. So we're starting with a square. We're creating a rectangle by shrinking one of the sides and stretching the other. We don't know how long the sides of the original square are, so let's use variables to represent them. X and x. Let's follow the directions it tells us for how the rectangle is created. We double the length of one of the sides. So this would be 2x. And we decrease the length of the adjacent side by 2. So this would be x minus 2. We're told that the perimeter of the rectangle is 10 feet greater than that of the square. So let's find the perimeter of the square. It's 4x. X plus x plus x plus x. Let's find the perimeter of the rectangle. It's 6x minus 4. Let's go back to that clue that the book gave us about these perimeters. The perimeter of the rectangle is 10 greater than the perimeter of the square. So the perimeter of the rectangle equals the perimeter of the square plus 10. Let's solve this for x. Subtract 4x from both sides. Add 4 to both sides. So x equals 7. We were asked to find the dimensions of the rectangle. So we need to take our value of x and substitute it in. We find out that the rectangle is 14 feet long. And the width of the rectangle would be 5 feet wide. Finally, number 44. A local train leaves the station and goes at an average rate of speed of 35 miles per hour. An hour and a half later, the express train leaves the station and travels at an average speed of 56 miles per hour. How many hours after it starts will the express train overtake the local train? One thing that will help us to answer this question is the formula distance equals rate times time. Let's make an expression for the distance that the local train travels. We take its speed, 35 miles per hour, and multiply by the time that it is traveling. Let's use the variable t to represent that time. Let's make an expression for the distance that the express train travels. We take its rate of speed, 56, and multiply it by the time that it travels. It's traveling an hour and a half less than the local train, so we represent the time with t minus 1.5. That 1.5 is the hour and a half less travel time than what the local train has been traveling for. Supposedly, the trains are going to meet up, so these distances have to be equal to each other. Let's make an equation out of that. 35t is equal to the 56 times t minus 1.5. Now let's solve this. Do the distributor property. 56 times t is 56t. 56 times negative 1.5 is negative 84. Now we could subtract 56t from both sides. We get negative 21t is equal to negative 84. Then divide by negative 21. We get t equals 4. T is the time that the local train was traveling, and those times are measured in hours. The last step of problem solving is to check your answer in terms of the original question to make sure you've answered what was asked. How many hours after it starts will the express overtake the local? The 4 hours was the time for the local train. The express train takes an hour and a half less than that. So the answer to the question is actually 2.5 hours. So this is a really easy one to get wrong, even if you've done everything correct up to that point. You have to make sure you're answering the question that was asked.